Hey guys, welcome back to another RASK Maths tutorial, and in this tutorial I'm going to be explaining how to use indices, the laws of indices, and also some examples to go along with each rule or law. So yeah, be doing them, I'll probably do it in bullet points, just so you can see the rules clearly and then you're working out beneath it as well. So let's get started. So the first rule you have to remember is a to the b. Sorry, let's use x. Okay, so let's say some number x, some number x to the power of a multiplied by the same x to the power of b is equal to, and that's equal to a plus b added together, like this. Because you can see you need to make sure that they're the same base. So I'll just label it in the side. Let's just put that in the side like so. So if you have x to the a, this is the base and this is the index or exponent, like so. So that's the labeling that we use, and you need to make sure when you're following this rule that it's in the same base. If it's just a random other number, then you can't use this rule. So I'll show you guys an example of this. Let's say we had 3 to the 2 multiplied by 3 to the 3. Well, that's going to be equal to 3 to the 2 plus 3, which is just going to be 3 to the 5, because 2 plus 3 is 5. And you can see this for yourself if you did the numbers yourself. So if you did 9 multiplied by 27, you would get 81. Sorry, you'd get 243, which is 3 to the 5, like so. So that's this rule. This is a pretty simple rule, and you also have the inverse of that. Not really the inverse, I don't know if that's the word, but if you have a to the b and divide that by x to the a divided by x to the b, that is the same as x to the a minus b. And you can actually see this yourself if you know some other indice rules, which we'll get into later, because you know that this can be written as, if you know how to do fraction division, you know that dividing something can just be written as the reciprocal of that. And you would know that this can be written as x to the a multiplied by x to the minus b. So then you can see how this adds. When you add these two together, you're going to get a minus b like that. But I'll get into those rules later. So there was this rule, and here was our example. Let's move on to the next rule. So the next rule is if we have x to the a and this is being raised to the b power, like so. So this is pretty simple. You can really just times both these together, almost like it's a normal bracket, like so, and you just get this. Because what this actually means is you're doing x to the a multiplied by x to the a multiplied by x to the a, and this carries on b times, like so. And so let's show you guys an example of this now. I can use the same example as before. So if we have 3 to the 2 all to the power of 3, well, that's just going to be equal to 3 to the 6, like so. And you can just see this for yourself, because this is the same as if we evaluate this bracket inside first. This is equal to 9 cubed, which I'm not actually too sure of off the top of my head. I believe it's 729. So if you type in 3 to the 6 into your calculator, you should also get 729. So you can see how this rule works. It's pretty simple. You just multiply these two numbers together. Okay, now we also have some sort of base cases, if that's what you want to call them. So you just need to remember that things like if you have anything to the power of 0, that is equal to 1. And if you have anything to the power of 1, that is just equal to the number itself, so x. And remember that you can never solve, if you want to say something like x to the, well, let's swap the order around. Let's say we have some constant k, and we want to raise it to a power of x. These are not the same x, by the way. They're just variable or random numbers. And remember, this equation can never be solved because x would have to be equal to negative infinity, which, as we know, does not exist. Well, it probably does, but for this case, it doesn't exist. So this equation, if you see something like that, just know that there's no solutions. No, let's just say no actual solutions. Okay, so those are some rules. Now I'll start talking about the slightly more complicated rules, but nothing too difficult. So for these examples, I don't really think I need to give an example, but I'll just do it anyway. So for x to 0, let's just say we had 3 to the 0. This is obviously equal to 1 because put any number here and it's always going to be equal to 1. And same thing here, 3 to the 1, well, that's just equal to 3. Because it's basically saying 3 times ... but this is only 1 3, so there's only 1 3 there. And the reason for this is because it's almost saying like 3 times ... but this is 0 times, and you can always write the identity element like that. So that's why you have the 1 instead of 0, as you might think when you're thinking about multiplication. So yeah, now let's start getting onto fractional indices, because these can actually be slightly tricky. So fractional indices, if we have x to the a over b, what this actually means is we have, we can split this up. So we can rewrite this using the rule up here. We can split this up into x to the a times 1 over b, like so. Because you can see when you multiply these two together, you're going to get a over b. And then what this tells us is if you have so I'll explain what this bit is here. So if we have x to the 1 over b, well, that is actually equal to the bth root of x. So I'll give you an example. If we have x to the 1 over 2, that is equal to the second root of x, also known as the square root. And if we have x to the 1/3, well, that's equal to the third root of x, also known as the cube root. So that's pretty simple. You just need to remember that if you have 1 over a number, then that's just equal to the root of that order. So if we put our knowledge back into here, x to the 1 over b, so we have x to the a to the bth root, if that makes sense, like so. So there we go. And it's also important to note that you could also split them up a different way. So if we instead split this up as x to the 1 over b multiplied by a, now you can see that we have a slightly different situation. We have the bth root of x to the power of a. And it's important to note that these two are equivalent. Sorry, these two are the same thing. So yeah, you can always use those. And let me give you guys a quick example for this one. I'll just rule this off like so. So if we have, let's have 27 to the 2/3. That is a good example. So if we use our definition from up here, we can rewrite this as the third root cube root of 27 squared. And if you do that, you'll see this is a very complicated, pretty complicated calculation to carry out. So we can use our second definition over here, and if we write this in, I'll just make a new line. If we write this instead as the third root of 27 to the power of 2, now you can see this is a much easier calculation to carry out, because we know exactly what the third root of 27 is. It's just 3. So rewrite this as 3 squared, which is just 9. So that's our answer. If you use this, if you type this into your calculator, you will also get the right answer, but it's a lot harder to do, especially on a non-calculated paper. So this is a much easier way of doing it. So now there's just negative indices to cover. And I've already covered them briefly earlier when I talked about this rule, the dividing rule, like so. And now I will explain why that happened. So what you need to know about negative indices is really easy. If we have x and negative a, this is literally just equal to the reciprocal of x all over a, all to the power of a. So put brackets around that, and that's equal to a. Now usually, if x isn't a fraction, then this 1 will always stay the same, because I'll introduce you to another rule. 1 to the power of anything is always equal to 1, because you know 1 times 1 times 1 times 1 is always going to be 1. And you might not want to combine this with the 0, anything to the power of 0 is always 1. Sorry. You might not want to combine this with 0 to 0 because it gets a little complicated there. But I'll let you know that's 1, but, you know, we move. So remember this rule, and then we can simplify this only if x is a whole number to 1 over x to the a. So now I hope you can see how this was helping in the earlier thing, because we can rewrite this as x and minus a. That is why that was really useful. So I'll give you one example for this. Let's say we have something like 3. I'm just going to carry on using 3. So if you have 3 to the power of minus 2, well, we can rewrite this as 1 over 3 to the power of 2, which is just going to be a 1 over 9, like so. And it's also important to note, just like the rule up here, the order you do them in doesn't actually matter. So what that means is you could also write x and minus a as you could just evaluate x to the a and then flip it like so. And that would be the same thing. So that's how, again, the order doesn't matter. In this one, it's not too important because you're going to be doing the same calculations anyway, but it's very important here to know there's 2 orders to do it in. So yeah, remember that. Anyways, now let's combine the information. So if we have 9, actually let's pick a different number. Let's say 64 to the power of minus 1/3. So this is combining a lot of indice rules, and I'll just rule that off. So let's use our indice rules. Let's first use this one, okay? So what we can say is we know this is just going to be equal to 1 over 64 to the 1/3, okay? Now let's use our indice rule from over here. So this can now be rewritten as, I'm just going to move this to the center just so it's easier to see. So this can now be written as 1 over the 3rd root of 64. And you should know this because it's a pretty common one. This is just equal to 1 over 4. And there we go. We've solved our problem. So those are the indice rules, which you probably should know. Thanks for watching, and I'll see you guys in a future tutorial. Bye.